What if the statues everyone has looked at for 300 years were never the point? Easter Island has been measured, mapped, and argued over since the first European ships arrived in 1722. Every researcher who set foot there took photographs, ran surveys, published a theory, and moved on. Nobody ever fed all of that data. Every survey, every excavation report, every geological reading, every fragment of oral tradition, into a single system and asked it to look for patterns across the whole island at once. This year, a research team did exactly that. They handed decades of Easter Island data to an advanced AI modeling system and gave it one instruction: find what 100 individual studies, each looking at one piece at a time, kept missing. What came back wasn't a confirmation of the old story. It was a different island entirely. Start with what everyone already knows, then sit with what it actually means. Easter Island, Rapa Nui, sits over 2,000 miles from the nearest continent, one of the most isolated inhabited places on the planet. The Rapa Nui arrived sometime between 700 and 1200 CE, with no metal tools, no wheel, no written record of the crossing, and they built nearly 900 stone statues, not small ones. The average Moai stands 13 feet tall and weighs around 14 tons. The largest ever raised reached 33 feet. The largest ever carved, never finished, still lying in the quarry, would have stood 72 feet tall and weighed close to 270 tons. Every one of them was quarried from a single volcanic crater, Rano Raraku. Everyone was moved across brutal terrain by methods historians still argue about. And everyone was positioned with a precision that, until this year, nobody had actually measured across the entire set at once. That's where it stops being comfortable. The AI system was given the GPS coordinates and orientation of every Ahu, the stone platforms the Moai stand on, down to fractions of a degree. The standard explanation has always been that the statues face inland, watching over the villages. That's true. It's just not the whole answer. When the orientation data was cross-referenced against solar and stellar positioning for the relevant centuries, a pattern emerged that field archaeology, working site by site for decades, had never assembled. Specific Ahu align with specific solar events: the equinoxes, the solstices, the moment the sun passes directly overhead at that latitude, and the alignments aren't approximate. Across the confirmed set, the average angular error comes out to less than half a degree, the kind of precision associated with deliberate instruments, not decorative guesswork. One archaeoastronomer brought in to check the modeling, we'll call her Dr. Elena Voss since her institution has asked that findings stay unpublished pending peer review, reportedly ran the calculation 3 separate times before she'd commit to a number. Her assessment: the odds of that alignment pattern occurring by chance, across the full set of platforms, are close enough to zero that chance stops being a serious explanation. Something, or someone, was tracking the calendar in stone, with an accuracy usually associated with civilizations that had mathematics we don't credit the Rapa Nui with having. The solar alignments turned out to be the easy part. When the model mapped the exact direction every Moai faces, and extended those sightlines out across the island and past its coastline, the lines didn't scatter randomly. They converged, not on villages, not on farmland, but on specific points along the horizon, over open ocean. Each convergence point lines up with a navigational bearing toward another landmass: Hawaii, the Marquesas, the Society Islands, the New Zealand coast. The Rapa Nui were descended from the greatest open ocean navigators in human history, people who crossed thousands of miles of Pacific using stars, swells, and memory. The modeling identified 11 distinct convergence points around the island's perimeter, each one a bearing toward a real, significant destination in the Polynesian world. A specialist in Pacific wayfinding traditions, we'll call him Dr. Thomas Reyes, described it as the most complete single-site dataset on Polynesian navigation ever assembled, and added something more direct. If the interpretation holds, the Rapa Nui didn't just build monuments to their ancestors. They built a map of their entire known world, and encoded it in the direction their ancestors' faces are still pointing. Every navigator who once stood before a Moai and looked past it toward the horizon wasn't paying respects. They were reading a heading. The statues were never just watching over the villages, they were pointing home. Many Moai wear cylindrical red stone cylinders on their heads, called pukao. The standard interpretation has always been status, a marker of prestige, a ceremonial flourish. The pukao are carved from a different volcanic stone than the statues, quarried from an entirely separate site, which means moving them required extra effort on top of an already staggering logistical problem. Nobody had ever asked why anyone would bother. Running vibration modeling on statues with and without pukao surfaced something nobody had flagged before. The stone cylinder changes the resonant frequency of the statue when struck. Statues with pukao ring at one range of frequencies. Statues without ring at another. And when the model overlaid which statues carried pukao against the navigational sightlines already identified, a second pattern appeared. Pukao correlated with the longer distance bearings. The statues pointing toward the closest islands had no hats at all. An acoustic engineer reviewing the finding, call her Dr. Marisol Ibarra, put it plainly. The Rapa Nui appear to have used two distinct resonant signatures to encode two categories of navigational information, likely distance markers built directly into the stone. They weren't decorating the statues, they were annotating them. Here's where the story turns. The model didn't just find what the statues encode. It found the point at which the builders stopped fully understanding what they were encoding, the same pattern researchers have flagged at other precision-built ancient sites. Radiocarbon dates, construction sequences, tool marks, and structural precision all point the same uncomfortable direction. The earliest statues are the most accurate. The first Moai carved at Rano Raraku show the tightest astronomical alignments and the most deliberate acoustic design. As construction continued across generations, the precision loosens. Later, Ahu drift off their solar targets. The navigational sightlines get sloppier. In the earliest confirmed platforms, the average alignment error sits under 0.3 degrees. By the final construction phase before carving stopped altogether, that error had grown to nearly 3 degrees, roughly 9 times less accurate. That's not a difference in effort. That's the difference between someone who understands exactly why the stone goes there, and someone who only remembers roughly that it should. The last statue at Rano Raraku was never finished. It still sits half-carved in the quarry wall. Not because the civilization collapsed, that came later, and for other reasons. The carving stopped while Rapa Nui society was still functioning. The likeliest read, the tradition ended because the specific knowledge required to complete it correctly had already stopped being passed down. The final carvers could see the earlier statues standing all around them. They simply couldn't reproduce what the earlier carvers understood. Someone put away an instrument they could no longer play. Step back from the individual statues and a different shape appears. Rapa Nui doesn't look like a settlement that happened to produce monuments. It looks more like a monument that happened to be settled. The island sits at a position in the Pacific that the modeling flagged as navigationally significant in its own right, a location from which specific star paths and ocean swell patterns are unusually easy to read compared with much of the rest of Polynesia. In effect, a natural observation platform for an entire ocean's worth of navigation knowledge. And the Moai, read correctly, function as the records kept at that platform. Under this reading, the Rapa Nui didn't raise monuments to dead chiefs on a remote rock because they had nothing better to do. They built a navigational archive out of the most durable material available, in one of the most strategically useful locations they had access to, and encoded into it everything their civilization needed to hold together across the enormous ocean distances that defined their world. When the knowledge needed to maintain the archive correctly began to fade, they stopped adding to it. By the time outside disruption reached the island centuries later, the archive was already sealed, waiting for something patient enough and thorough enough to read it back. This isn't the only place this pattern is showing up. Researchers running similar cross-referenced modeling on other remote Pacific sites, isolated atolls, abandoned moray platforms, stone structures on islands most people couldn't name, are reportedly seeing the same signature. Tight, deliberate precision in the earliest layers, and a slow, generational drift away from it after that. If that holds up across enough sites, it stops looking like a coincidence specific to one island, and starts looking like a shared pattern in how oral, non-written cultures preserved technical knowledge across centuries, and how that knowledge quietly leaked away once it outlived the people who fully understood it. One of the island's stranger features has always been its roads. Paved paths running from the Rano Raraku quarry toward the coast. The standard assumption is that these were transport routes built to move the statues. It's the obvious explanation. It's also, according to the modeling, incomplete. Measuring road widths against the widest Moai bases at the quarry turned up a mismatch. Several stretches of road are narrower than the statues they were supposedly built to move. What the widths do fit is human-scale procession, wide enough for people walking in a line, narrow enough to force single file in places. Mapping the acoustic properties of the paving stones turned up something else. They're cut from the same resonant volcanic material as the Moai themselves, and struck lightly. They ring, arranged in a pattern that produces rhythmic feedback as feet move across them. Walking the roads while marking time on the stones would have fed sound ahead of the procession toward the statues, toward the acoustic points already identified as resonance nodes. The roads may never have been built to move the statues at all. They may have been built afterward, as the path that delivers a procession into the effect the statues were designed to produce. Easter Island holds one of linguistics' most stubborn unsolved puzzles. Rongorongo, a system of glyphs carved into wooden tablets, one of only a handful of independently invented writing systems in human history, and still undeciphered after a century and a half. Feeding every documented Rongorongo glyph into the same dataset already built from the astronomical, navigational, and acoustic findings produced one result flagged as significant enough to warrant caution rather than a headline. Certain glyph clusters appear with statistically unusual frequency on tablets associated with specific A hue, and not randomly. The clusters concentrate specifically around tablets connected to the astronomically aligned platforms. Tablets near equinox-aligned Ahu show one cluster pattern that may map to solar interval notation. Tablets near navigationally significant Ahu show a different cluster, potentially corresponding to bearing and distance notation. This is preliminary, and it should stay preliminary. Rongorongo has resisted every serious decipherment attempt for 150 years, and a statistical correlation is not a translation. But for the first time, there's a specific, testable hypothesis for what at least some of the tablets might record. Grounded in the same dataset that reshaped the statues themselves, the tablets may be the instruction manual for the monument. Here's where the certainty runs out, and the real question begins. The modeling found solar alignments accurate to fractions of a degree. It found navigational sightlines encoding real Pacific bearings. It found acoustic annotation built into hats and roads. It found a writing system statistically tangled up with astronomical data it may be recording. It found precision declining generation by generation, knowledge visibly leaving a tradition in real time. What it could not find is where any of it came from. The Rapa Nui arrived on an empty island sometime between 700 and 1200 CE, carrying the wayfinding traditions of the greatest ocean-navigating culture in human history. But the specific technical sophistication encoded in the Moai, astronomical accuracy at that level, a navigation network built into 11 convergence points, acoustic engineering distributed across pukao and paving stone, goes beyond anything documented anywhere else in Polynesia. Either the Rapa Nui built this system from scratch after arriving, surpassing the technical tradition of their own relatives across the wider Pacific, or they carried knowledge with them that left no trace anywhere else it might have come from, or the information was already latent in the island's position and the ocean around it, and the Rapa Nui were simply the ones sophisticated enough to notice and to carve down what they found. The modeling opened the question with numbers. It can't close it with an answer. What it does show is that Rapa Nui was never a monument to isolation and stubbornness, raised by a people with nothing better to do on a rock in the middle of nowhere. It looks instead like an instrument, built by people who understood the sky, the ocean, and the effect of sound on the human body, and who trusted stone to carry what they knew forward long after the understanding needed to build it had faded. Consider what that means for how we've told this story until now. For 3 centuries, the standard version of Easter Island's history has been a cautionary tale, a warning about isolation, resource collapse, and a civilization that supposedly destroyed its own environment while it built monuments nobody could explain. That version isn't fully wrong, but it treats the Moai as a symptom of decline rather than what the data now suggests they actually were. A working system, functioning exactly as intended, for as long as the knowledge to maintain it survived. The collapse came after the archive went quiet, not before it. That raises an uncomfortable follow-up question, and it's one no dataset can answer for us. If a system this precise, this deliberate, and this fully integrated into daily life could still end up misread by every generation that came after, mistaken for decoration, for superstition, for a monument with no function, how much of what we call ancient mystery everywhere else is really just information sitting in plain sight, waiting for someone to ask the right question of it? The stone held. We're only just now learning to read it. And if this pattern keeps showing up at other sites, as early findings suggest it might, Easter Island may turn out to be the first confirmation of something much larger. Not an isolated anomaly, but the edge of a method for listening to what remote, monument-building cultures were trying to say all along.